Hello everyone, my name is Philipp Bauer and I welcome you to today's Code Presents. I will show you how you can build intelligent agent systems using Semantic Kernel today. Let's take a look at our agenda for the day. So first off, we will take a look at the basics of Semantic Kernel. What is a kernel? What is that all about? If you don't know yet, you'll get a good idea of how you can get started with this. We'll take a look at simple chat agents, just a stepping stone so we know what's going on in general and how we can communicate with large language models. And then we will go right into function calling. So function calling is a really interesting topic, of course, right now. You can extend a large language model using tools that can access data on your systems or reach out to the internet to do a web search, all those kinds of things that it can do. And while we look at function calling, we will also talk about how you can build your own plugins using native C# code. And we will build on top of that later by looking at how you can integrate MCP servers as well. After doing function calling, we will take a look at our first agent, and we'll talk about what an agent is, what differentiates it from just a regular function calling chat, and how you can use it to then later use multiple agents to orchestrate them to do functions that you want to have done. All right, so this is going to be a more or less live coding situation. We will have a lot to talk about, so most of what you'll see will be copy and pasted, so I don't bore you to death by just typing it all in. But we will go through each pieces of the code, and I will explain to you what's going on, what's happening, and how you can integrate this yourself. Let's take a look at the CS project file first. What I did here, of course, is I simply created a new .NET console program. I then added a solution, and I added some of the already existing helper methods and all of that that I will later need when we build out our chat modes to visualize the output. So let's take a look at this here CS project file. There is nothing too surprising here. What I do have to point out is that there is this no warning tag here that just suppresses the warnings that come from Semantic Kernel, because there is some experimental code in there that will throw an error. Just so you're aware of that, when you build anything on Semantic Kernel, there are still portions that are experimental and they may change. But besides that, packages pretty much as usual. We'll have some configuration packages here, nothing very surprising here, something to log. Then we have our Semantic Kernel packages here. And these two are the most important ones if you want to get started. With agents, this is what gives you the basic functionality, so to say. Then for orchestration purposes, we have the orchestration package here and the runtime in-process package here that just gives us an in-process debugging or development runtime. And then, of course, we will look at the Magentic chat mode later, and that comes with its own package that you'll have to install for that. Then we have the Model Context Protocol package here that gives you the ability to create or wrap your MCP server, something that's coming from Node, for example, into something that we can use in C#. And then in the end here, we have Spectre Console. It's just a library that helps pretty print in the console, because we don't want to have to look at a whole mess of output and logs later on while we interact with our chatbot. Next up, I have my program CS here, and that's currently empty. We will add a couple of things so I can explain them here. So first off, we need to import some configuration code. Let me do that here. Let's go to the other screen real quick and pull in the configuration code. Nothing surprising here. We're just using the configuration builder here to add the app settings, environment variables, and user secrets. So the user secrets will have things like my OpenAI API key that I can share, but we can have a look at the app settings here to understand what settings we will actually import. We can do that in two ways. I, of course, bind them to an app configuration object here, and that app configuration object looks like this. There's a OpenAI section, a memory provider section, and an actual budget configuration setting. We've you are all familiar with OpenAI. That just configures our model ID, our API key, and the endpoint. The memory provider gives us an API key. This is for the mem0 service that we will have a look at for our little bonus later on, how we can have a chat mode or a agent that has some sort of memory pretty much built in. And then we have an actual budget configuration. Actual budget is just a little self-hosted application that provides me with an API that I can use to demonstrate that you can do some useful things with these agent orchestrations as well. And I built a little MCP server around this that's hidden in this actual MCP file folder here. And that is basically a Node.js wrapper around their SDK. Then we'll take a quick look at the app settings. Nothing too surprising here either. Currently configured OpenAI with localhost LLM service, LM Studio. But in the secrets, I have them overwritten to use OpenAI's API, a little bit faster than my laptop. Then we have that memory provider, actual budget, and some login configuration. So all pretty much standard stuff. All right. Then we will take a look at what this is real quick. ANSI console is for that Spectre console. It's just to do some pretty printing. It will surround a few pieces of the code that we will take a look at later. And I just don't want to go too deep into that. It's just to pretty print some stuff. All right. With that, without further ado, let's take a look at what the kernel in Semantic Kernel is. So the kernel in Semantic Kernel is basically a dependency injection container. And that is very, very similar to what you have in .NET overall, like the host builder that you have, pretty much like that. You can add services to it, you can add dependencies into it that your agents can later use, things like that. So how do you build one? If you have ever done an iHost builder configuration, then this will all be very, very familiar for you. So you start with the kernel builder, and I will have to turn off Copilot. Let's just do that real quick here. Snooze it. All right. So you will have to get the kernel builder going by doing kernel.createBuilder, like so. And then you can add your services to it. In our case, we want a chat completion. And there are a few available here. So you can see there is the Azure OpenAI variety here, and you can do all kinds of services, audio to text, a chat client, chat completion, embedding generator, all those kinds of things. And down here we have the OpenAI versions of that as well. I'm using the OpenAI versions because I want to be able to use any OpenAI API compatible server, anything that's LLM, Llama CPP. I need to cut this out because I want to be able to use OpenAI API compatible servers like llama.cpp, LM Studio, VLLM, those kinds of services. Azure OpenAI has its own kind of protocol to connect to it using endpoints and deployments and API keys. So that's not really working for me here. So the chat completion, again, needs a model ID, an API key, and an endpoint. And so I don't type all of that manually. I'll just copy and paste it here. There we go. And with that, we have our kernel builder completed. And now we can build our kernel, the kernel itself. And that is, again, very similar to host builder. Now we can just do kernel builder and build, just like so. And now with this kernel, what we can do, currently there's just that AI chat completion service in there. But at this point, we could add plugins, for example. Plugins are what you would call tools in other places. So a plugin has multiple tools, and we can inject them at this point in our kernel. What we can also do, what I think is really nice, we can clone a kernel so that we can use a common core and then add more functionality to these clones. And they can be short-lived. You can instantiate a class that is an agent. The agent has its particular plugins, for example, and it only lives as long as the agent lives. So that is a very good way of managing different plugins, different functionality within your application. Let's look at how we can set up that chat service that I was talking about. It's fairly easy. It's basically just getting a service out of your dependency injection container. So let's get the iChat completion service here, and we call that chat service. And there we will just say kernel get our required service and the iChat completion service here. So with that, we have something that we can use to run inference with. We need a couple of things to add to this, not much. Let's just add a throw here. And now we create a simple chat loop. So for that, outside of a loop, we'll take a chat history on here. And that's basically a list of multiple chat messages. Think of it like that, just one after another in sequence. And then we'll just add something here. Copy this. All right, so since this is going to be an ongoing conversation, we have a simple loop that gets a user input that we prompt for. And then if the user says exit, we exit out of the loop, or if we have an empty string, we also break out of the loop here. So far, so good. Let's add something more here. So we stayed organized during our session today. I added all of these modes as simple chat mode classes. They're static classes that I just add my services that I have here outside of my loop, and they will basically just obscure some of the craziness later on, because we try to go through a bunch of different chat modes. All right, so the simple chat modes that I have prepared here are already in my chat mode folder. And these are really simple, so I won't spend too much time on them. But I want you to understand that all of these things build on top of each other. So we have our kernel. Our kernel enables us to do a simple chat. Our simple chat enables us to do function calling. Our function calling capabilities enable us to create agents that can act on our behalf. And then the agents can be used to be orchestrated into different kinds of orchestration patterns that can do larger tasks even on an automatic basis. So that's why I think it's important to just brush on these easier things. So let's take a quick look at this. And I add to the left here our loop, just so that you see the context still. So we get our input from the user, gets prompted, gets passed on. Our chat service that we created in our kernel is getting passed through here, and the chat history as well, and then we have the input. And when this is done processing, it will loop back and start all over again. So with that in mind, some things may not make sense usually to be put in here. You will see some of this that you would normally put outside of the loop, but that's just to make things a little bit easier for us right now. So for a simple synchronous chat mode, what we do is we can simply add our user message to the chat history. This is now the first and only message in this chat history. This will then be passed to our chat service here, and we can await a response. We just simply call get chat message content async with our chat history. And then we add the assistant message to our chat history for later, so that when we come back around, we have that in the history as well. And then we just use our little format helper here to format the last chat message. So let's take a quick look at this and see if this works. There we go. So as you can see, my configuration that I have loaded is GPT-4 Mini with my API key on this particular endpoint. And now I can ask, hello, introduce yourself to Code Presents audience. I see my office dog is awake. That is sunny. So, hello Code Presents audience, I'm ChatGPT. You can see this is a simple chat mode that we can now send messages to. So, simple stuff. Nice to meet you. Great. Now we can exit out of the program. That is the simplest way to use Semantic Kernel, basically. or get a chat going with Semantic Kernel. So really, if you look at it, there are not many moving pieces here. We created our kernel builder, created a kernel from that. We extracted our chat service from the kernel, and we use this chat service to then process an input in the chat history. So not many pieces really around it. I had to make it a little bit complicated for later purposes and that so we can actually interact with it. So apart from that, very easy stuff if you think about it. Let's take a look at what this looks like when you use asynchronous processing. Let's open this one up, asynchronous chat mode. So the asynchronous chat mode here works in a very similar way. You add your message to the chat history, just like we did with the synchronous one. And then you call, instead of your get chat message content async, you call get streaming chat message content async. And you place this, since this is an iasync enumerable type, you place this into an await for each loop. And you get little bits of your message back instead of the whole message. So what you have to do is to use a string builder, for example, to append all of the chunks that you get from your message to your final content. And in this case, all the temporary content, or the content that is still streaming from the server, is here in my content to string, and I can update the panel that you saw earlier here. These kinds of panels can be updated live as well. So I do that, and then when I'm done, I add the add assistant message to the chat history, just like I did with the synchronous chat mode as well. So let's have a look at what this looks like. This is the more familiar chat experience that you would see in an online interface. Please introduce yourself. And I cannot type today. There we go. There you go. And this is just the streaming variant of a simple chat. Next, we will talk about how you can add functionality and do function calling. To do function calling in your chat, what you'll have to do is add a plugin to your kernel. And how you can do that is what I'll show you now. So we'll create a new function calling chat mode now. This one, it's a new file function calling chat mode. We can close these here. So the function calling chat mode will not only use the chat service, it will also use the kernel here. And what we'll do is, first, we will clone our kernel and add tools to that kernel. So let's do that first. In here, and again, this is in our chat loop, and we just, place that in there. What we do first, our kernel, we need a second kernel, cloned kernel, equals clone. There we go. And to this cloned kernel, we can now add some functionality. On the cloud event, on the cloned kernel, plugins, and then I can do add from type. And I have an email plugin that I will show you in a second. Well, if I can type, there we go. So this email plugin is pretty simple. I just need one more thing, email plugin, because this expects a plugin name. So this email plugin is fairly simple. I have a list of emails, and that it has a simple email model with an ID, a sender, subject, body, things that you would expect for an email. Each of these emails that I have in here is just a little test data to give us something to work with. And they have different received at dates so that we can use some sorting and things like that. Then we have simple functions that we can use to work with these emails. And this is how you can use native C# code to create plugins for your agents. The simple thing that you have to do, in addition to building a class, a plugin, you just annotate your methods with names that can then later be parsed or taken from your class here and injected into the context of your language model. So it will then get a list of tools that it can call. And you might have already seen that. It's like a JSON format that has the function name, a description of what it does and what it's used for, and then also a list of all of the arguments that it can take and what type the argument is, and more details about them. So what you would do is you name your kernel function by using this attribute here, and then give it a description like this. When you have any parameters that you need to set, any properties that you need to set here, you have the description for each and every single one of your properties. So description, and then the compiler will take care of your type and name of the function for you, of the property for you. Again, pretty straightforward stuff here. You can now ask, for example, to get a list of all emails, and it would return a list of these emails that we have in here. And let's continue on with the function calling that we are already familiar with now. We just add one more thing to it, and that is a system message. Since this is not just a simple back and forth chat now with some language model, we have expectations, so we need to communicate them. And I add the system message to add the instructions that I want this little chat bot to have. Very simple stuff. And from there, it's really not any different than from the regular function calling. So I just copy and paste the rest of the code in. The only difference that I need to add here still is one thing, and that is the function calling behavior. For the OpenAI API, it only supports the auto behavior, but you have more behavior options here. You can select none so that no functions will be called. And then there's also the required one that in turn requires at least one call of one function. But we keep it with auto here, which by default is the way to go. So with that, we now get our get streaming chat message contents here as well. What we do add here is the execution settings that we just set up, and we also inject our cloned kernel here. All right, with that, let's try this out. We can now have our first function called. .NET run. How many unread emails do I have? So what we see here now is that the assistant chose to call two plugins, one plugin or tools. One is the count emails tool, and one was the count unread emails tool. And neither of them have any arguments to set, so no arguments were set. And then we have in order the results of those tool calls here. And then the LLM is synthesizing the final message here. You have a total of 3 emails in your inbox, of which 2 are unread. That's how you can do function calling. Now I can also ask more. List them. Simple as that. Now it would invoke the get unread emails. Well, I could have specified, although I did specify unread emails here, it served up both of them, and it continued on with the get unread emails here. So very good. It found those 2 emails, and then it created a list. Now I could ask it to show me Alice's email. Well, smarter agents would be better with this. Usually it does it too. So, but let's try this. We have it. All right. Well, the demo gods are not with me. Show me. Let's try this one more time. Alice Johnson's at example email. Ugh. All right. Well, this one is not wanting to be cooperative today. Well, you can't have it all, I guess. But it has worked before. Maybe GPT is not the best one, not in best form today, but we'll take it. All right. If we need to, we can always fall back to local models. They're way better anyways. Good. We won't let that slow us down, and we'll take a look at how you now can go from a function calling mode to your first chat agent. You will see slight differences in how we do things, but really only marginal. What the difference is between what we've done now with function calling and what we'll be doing now with an agent is that instead of using the chat service, we use an agent to invoke our prompt. And we also advance a little bit on our use of the chat history, and we'll use an agent thread. And this agent thread has a chat history itself. We can just do new with our chat history. If we want to continue a previous chat history, we can wrap it in an agent thread as well. But what this agent thread does is it manages under the hood the chat messages that the agent manages, basically. Because now we have an entity, so to say, that can send messages as well. You can think about what to do and send another prompt. And it's not just user-driven anymore. Now it's AI-driven. So let's have a look at how a chat mode like that looks like. So let's create it. A new model here. Just copy and paste this one in here. And then we'll build up from there. So here now we pass the kernel, the agent thread, and our input. If our input equals new thread, we'll create a new thread that will allow us to continue with a new chat session in our interface if we need it. Here we now will create our clone kernel as we've done earlier for our function calling chat. And it's the same thing, clone kernel with the email plugin. And now we start to, instead of using the chat service and a system message, we'll create a chat completion agent. And this is how that works. So we have a chat completion agent here, and you can add, some of these are optional, but these fields will have name, a description, then the instructions, and the instructions are basically what we had in the system message. So now each agent is set up with a system message or instructions that it can use to guide its behavior. And all of these agents will then be able to later, when we orchestrate them, use a common agent thread to pull from. And it will be able to react on the thread, on the content of this chat history in the agent thread based on its instructions. So think of it as many little function calling chats that are encapsulated and can just run automatically. Here again is our OpenAI prompt execution settings, not to be forgotten. And then we'll do some simple output here. For now, again, nothing too complicated, nothing that you haven't seen before, really. Somewhat out of line there. Var agent, okay, this is where I wanted to go. So I'm just skipping a message here because that's our input. I don't want to repeat the input from our prompt in our later when I render the output. And then again we get into this part here. We again have an await for each. Now, instead of using, as we did the function calling chat mode, instead of using the chat service here, all right, we use the agent and invoke the streaming agent method here in the agent. And the agent then gets the input from the user and the current agent thread. The agent also handles adding messages to the chat history in the agent thread, so you don't see me doing that manually anymore by calling the chat history at assistant message. It's basically doing that internally by itself. So I just read them and in an effort to then update our on-screen target, our panels that are currently still streaming content into a panel that is active. All right, so that is the basic agent behavior. Again, clone kernel, we set up an agent that is essentially its own encapsulated function calling chat mode. And then we call the agent instead of our chat service. Let's make sure that that is saved here as well. Run. Okay, now we have a chat going on with our agent, and I want him to list all my emails. There we go. So you'll see that not much has changed from the function calling chat mode. The only thing that's different really is that now we have our email agent name here instead of just assistant, but it also just called our get emails tool without arguments. It then followed the instructions that we gave it and output that as a list. Now let's see if the agent show me Alice's email. Let's see if it can get it right. There we go. All right. This is what I expected earlier too, and usually it worked, but now we have proof that the LLM is not completely incapable. So that is a simple agent that you can use. Now, again, this is not much different from just doing a function call, and you could use an individual agent like this, but that's not really the point. What we can do with this is going to orchestrate. And there are several different orchestration modes or patterns that you can use. And some are more useful for different scenarios than others. There are concurrent patterns. Let's just go through them real quick. The concurrent pattern broadcasts a message to several agents at once, and they all return with their results independently. So good if you want to do multiple things, maybe the same thing at once multiple times. Then you have a sequential pattern. That's a simple sequence where input gets passed to one agent and its output gets passed as input to the next agent, sequential. Then we have a handoff pattern, and this is where things get more interesting. Now we go into self-organized working agents. And handoff, this is something that I'll show you. I think this mode is pretty flexible, pretty good to use for several tasks where you want to be a little bit more in control, so to say. So handoff pattern basically defines several agents and their relationships to each other and how they can interact with each other, who hands off to whom, and can then go until either a task is done or a maximum iteration is reached. Then we have the group chat mode. This is done by adding agents to a group chat and a group chat manager who manages this group chat. The group chat manager can come in different ways by default, and if you look at the documentation, there is a round robin manager, but these can be implemented however you really like. The round robin one would just go one after another and over again to call one agent after another. Basically a sequential one, but in a loop. This can be, again, done with different implementations, and I leave that for you to explore. And then at the last here is the Magentic pattern. It's based on the Magentic 1 agent network. It is a completely self-organized way of several agents to work on a problem together and contribute to that. There's very little direction given by a developer, but you can, and I will show you how to kind of break open that box to not only do some inspection of what's going on under the hood, but also how you can influence how things are actually done with that. Interesting stuff. So without further ado, let's take a look at the handoff pattern. I will activate this. Let's close these things out. And while we look at this handoff pattern, I will also show you how to add an MCP server as tooling. Let's grab that here. Okay, so pretty much the same that we saw just now with the completion agent chat mode. One small addition here is that we are passing the app config in as well. All right, so let's take this bit by bit. First off, what we will add is our email agent. So let's take that one. You already know it, so we won't talk too much about it. I'm just missing closing brace. So here we clone our kernel now into an email kernel. We add our email plugin, and we create our chat completion agent for our email manager. I added a date here for today as well, so that it's aware of what day it is. This is something that we'll take another look at in a little bit when we take a look at the agents up here. There are some interesting things that you can do with the instructions to help your agents along. Now, let's have a look at how you can create an MCP plugin. And what I would do here first is I'll take these two lines. So I'll start a finance agent now. And this finance agent is just, again, using that MCP server that I have for my actual budget server. So as you can see, I wrapped this into a function because there's some stuff going on here. What I really need to pass here is my actual budget configuration. Now let's take a look at what's happening under the hood. So we expect a server URL, a server password, and a budget ID. So we can connect to the server and we can select our working set. We also need a temp date ID. This is just a temporary folder on my system. And we need to have the correct path to the tool if it's not installed as an application that you can reach in your command line, for example. So what I have done here, as part of my project, I added the Node.js code here, right? So because I've done that, I am currently, need to add this. So what I want to do here is I want to build my MCP server as part of my project. So I do that by moving into that folder and then run npm install and npm run build in my project here. And then when I build it, I also want all of these files to be put into my output folder. So then when that is happening and all of this lands in my folder, I can then get into my app directory and get into here. Or, well, if you actually ship this, you would, of course, go and use your binary folder because we did copy everything in there. Be that as it may, we use basically a path. We call our MCP server here as a JavaScript file with Node, and we could call any kind of executable really with this. It's just part of how this works right now. I display that information here for debugging purposes, and then we get to the real heart of it. Now, this MCP client here is coming, as you can see, from that Model Context Protocol NuGet package that I pointed out earlier at the beginning. So this is what we use to create an MCP client that's compatible for us. We can define a standard input-output client transport. So again, like we can call this like any tool on our CLI. Then we have our name for the MCP client, which in this case is actual budget. We have a command. This is the command that is that is executed on the command line, in this case node, because we want to call our build MCP server with node, with the arguments that we created earlier, the MCP server path, and with environment variables. These environment variables include the server URL, password, and budget ID, but also that data dir that I created earlier on my temp folder. Then this is all dependent on your particular MCP tool. In this case, I also had to set a flag that it accepts unsecure or self-signed connections. All right, so this will be then returned to my MCP client here in the handoff chat mode. And then we can extract the tools. So all of these tools can be taken, and then we can use that to add these tools to our kernel. And that's what we're going to do. So just as we have added plugins here to our email kernel, we will now add plugins to our financial kernel, and we'll use the add from functions method instead of add from type. And we give this a plugin name, In my case, it's just budget, and then the tools that we want to add to them. So these are all kernel functions. You remember probably kernel functions from our email plugin. That's exactly what we have here, kernel function. Just similarities all over the place. All right, so with that, we can now create our finance agent. So let's copy and paste that in here. So here we again have a simple agent, finance agent. This finance agent has access to all of the tools in this budget, and it should use them in a defined manner. And that is our agent number 2. What we need next for our handoff is a handoff agent, and this is a fairly simple one. It doesn't really even need any It doesn't really need any plugins for doing its job. Its purpose is just to say, hey, this user request is best served by agent X or by agent Y. So in this case, it'll determine, hey, is this something that's email related or is this something budget related, let's say. Now we have to define the relationships between our agents. And the way that you can do that is by creating a orchestration handoff. Basically a list of definitions here for what it should do. So it should always start with an agent. In this case, our handoff agent, because it will evaluate the agent that should be used next. Then we add the handoff agent as the source, and then the agents that it can route to. So in this case, handoff agent, email agent, finance agent. And then we add the reverse. We have our email agent that sends a request to the handoff agent if this issue is no longer email related. And the same for the finance agent. Because then we want the handoff agent to go ahead and look at where to route again, either back to the human or to another agent. And talking about that, back to a human, a very big and important thing is to have a human in the loop. So let's take a look at how you can do that. So to have a human in the loop, we basically need another prompt. And the orchestration needs to be able to somehow invoke a command to get that. So that's what we have this interactive callback for. And we will add that to our orchestration in just a minute. This is very easy. It's kind of a branch out to send a prompt out to the console here, or interact with your UI, however you have implemented that, and then return that as a chat message back from the user again, back to the AI. I will also, before we start with the actual orchestration, something else that we will use in there is a response callback. In here, now I take over the responsibility because I put this in here, I overwrite this. I take the responsibility to add these as messages to the chat history. The responses are usually not shown to the user. I do that because I want that as debug output, and I add the debug output basically into our chat, so we can just take a look at how the agents internally are communicating things. And I will use the display chat message from my formatting helper to pretty print all of that. So normally you might want to just send this to some logging target or something of the like, but you don't need this to display the final message. The final message will be a result later on. So let's take a look at the actual orchestration, or at the and how you begin to start the orchestration itself. So far we had setup, we have defined our relationships, we have defined our interactive callback to keep the human in the loop, and we have a response callback to inspect the agent chat internally. Then here we create a new handoff orchestration class, an instance of it with our handoffs, with our relationships, and then we list each and every one of our agents that is involved. So as you can see here, we have our handoffs and then an agent for all of the members. And then we also add our interactive callback and response callback. Now, earlier, this is not something that we have much time to discuss at all, so we'll just leave it at this. We need a runtime for our orchestration, something that keeps things going. In this case, this is just using the internal in-memory runtime, process runtime. So we just create a new one of those and start it in preparation to actually invoke our orchestration. And to invoke our orchestration, now we get back into a little bit more familiar territory. We have, instead of chat servers or agent, now we have the orchestration that we can use the invoke async method on with our input. And here we specify our runtime. So then, because this is, it will be a fairly long running process with maybe multiple calls to interactive callback and response callback. All of this is now basically running. And we wait for a result. So this orchestration needs to run its course and come to a conclusion, and eventually it will return an output. And this output is the final message that we will then want to wrap, in my case, wrap into a chat message content. Again, this is just the actual content, and then I want to display that. The agent thread itself that we have up here already has that last message in it, in its chat history. So I'm not going to access that and add it to the chat history in this case, just as I stopped doing with the other, with the regular completion agent as well. All right, let's have a look at this and see if it works. Might just be that. There we go. So I have now a handoff agent. So as you remember, our handoff agent is the first one that we want to start with. And it determined that it needs to pass on to the email agent. The email agent then in turn decided to use the function count unread emails. It then returns to me, you have 2 unread emails. Would you like me to list or read them for you? So let's have a look at this just with a thinking model. I'll start this here. Select the model. There we go. Found them now. Let's take a small one here. Load model. It's loading. There we go. And we turn enable thinking on. Let's do that. I will temporarily disable OpenAI. Run this again, no build. And we should get some thinking output while it thinks about what to do next. So, how many unread emails do I have? No. So as you can see here, it now has thought about what to do. Now we get a little bit of a with the thinking mode on, which again is not necessarily the best thing to do with agents. Oftentimes they kind of get hung up. I've found that with small models it sometimes helps, but if you use GPT-4.1 Mini, for example, or other bigger models that can think, sometimes the improvement isn't that great. So let's just use this as an example of what's going on under the hood, so we have a little bit something to go on. So the decision is made that an email agent is the most appropriate one for our query to resolve. So that's all going on in the handoff agent. We don't see any output here because of the way things are structured in general, but we can see a thinking output if it has it. So that's why I'm demonstrating it with it. The message basically gets more or less passed on to the email agent as is. It then decides to come to use the count unread emails here, and then it thinks further. Now let's have it switch context and ask what my current budget on, or my balance on my checking account is. And what is the current balance on my checking account? Okay, this is something that sometimes happens with especially smaller models. It can't really think enough, not intelligent enough to come to the conclusion that, hey, I'm I don't have access to financial transactions. I need to hand this back, even though I'm telling it to. If we take a pretty close look at these descriptions, at the instructions here, I tell it to use the handoff plugin to transfer the conversation to another agent, pretty specifically, because I ran into these issues. This is mostly for very small models, 4 billion parameter model. It stretches it a little bit, so not that surprising. Let's switch this back to OpenAI. Run this one more time. But I want you to have in mind that it, under the hood, makes these decisions. There is something going on. It's not just a mechanical kind of thing. It's actually the large language model underneath that makes the decision to hand it off to a different agent. So again, how many unread emails do I have? Let's see if this switching around works out now. Transfer to email agent, unread emails, 2 unread emails, great. What is the balance of my checking account? The demo gods. Let's see. I want this to work for you. So let's see if instead of 4.1 mini, the full 4.1 can do it. Just to ensure you that we can actually check the balance of the account. What is the balance of my checking account? So I still have to prove to you, after all, that the MCP server itself is working. So in this case, we transfer to the finance agent. It then should be looking into my account, and it did that. It got the accounts, which is a list of just the account names and IDs, and then it grabbed the account balance with the tool that it has. The API value, well, this is an instruction thing. I would assume it's actually $10,025, not 10,025 cents. But since it is common for financial systems to utilize cents as their base unit, it's fair for the agent to assume that it's cents and convert it to $100.25. That's fine. Let's see if we can do it the other way around. How list my emails? It's my unread emails. Let's try that. Maybe the other way around works. Here we go. All right, this is now expected. So it transfers it to the handoff agent to the email agent, and the email agent now should be calling my tools to then show me all of my unread emails. There we go. One line too many, but that's fine. All right, well, that is handoff for you. Let's take a look now at, we can't exit like this anymore. Now let's take a look at the Semantic One orchestration. The Semantic One orchestration kind of has the idea that it is completely self-organized, that it gets a whole bunch of agents and its capabilities, and it can then pick and choose which function to call, which tool to call, and how. So it actually analyzes the request, then makes a plan, and also follows or has like a ledger of what is currently happening, what the agents are working on, what the next steps are we stuck in the loop, all those kinds of things. So let's have a look at all of that. And what we will do, go back to our program, as we've done before, create a new chat mode here, file. Let's copy what we need to get started. Okay, and again, this is very similar to what we had previously in the beginning, but then changes a little bit. So again, we have our app config here, the kernel, the agent thread, and our input. We also, for this, want to have an interactive callback function. Again, same thing as before. We then need a Magentic manager. And this Magentic manager is kind of what coordinates the different agents. It makes sure that the right agent gets called, it makes sure that the plan is made and updated, it makes sure that all of the agents stay on track to fulfill the request the user made. So you can go with the standard Magentic manager, but I want to show you something a little bit more advanced. The manager that I created here is called Logged Magentic Manager because I added some output there. And we'll have a look at this in a moment. Let's continue with our setup. We add some prompt settings. So these OpenAI prompt execution settings now also get a chat system prompt if you want. This can be, of course, omitted. This is completely optional. I was experimenting with some thinking models, different sizes, especially local ones, to see how well they behave, and where thinking and non-thinking models are better or not in solving these problems. One of the things that I added here is an instruction to keep thinking concise, because some thinking models just continue and continue on and think about the same thing 5 times. So I try to reduce that. Now for the model that we're using, this is not necessary, but it's good to know that it's there if you need to add some more instructions to your orchestration. Now again, just in a similar way to how we have presented agents to the handoff orchestration, we need to have some agents ready for this one as well. And what these agents are doing, they are all built on top of the actual budget MCP, but they all are doing one specific function. So let's have a quick look at how you can create a little bit more advanced agents here. I have a class that has as an interface basically a create async method here that creates a chat completion agent. And in here I do my setup for it. I get my agent kernel, my tools from creating an MCP server or client, MCP client, as I've shown you earlier. And then I utilize some of this in my instructions even. Let's actually grab one of the ones that actually does that. My bad. Here we go. So this administration agent, this is kind of the, it includes all of them. We're not going to use this particular agent, but as a demonstration of what you can do, I used some of my tools to basically seed my instructions with some actual data from the from my endpoints. I do this so that the instructions have certain bits of usually non-changing information or slow changing information from the system, like the available budget accounts, on-budget accounts and off-budget accounts here, so that it wouldn't have to do the call out to a tool when the user asks for it. It already has some of this information just at hand. The same thing goes with date times and in this case a default date range that can be used to as filtering functions, for example, default filters. So all of that is possible. Just think about how you can enrich your instructions to make your orchestration or your agent in general the most efficient as it can be. Okay, so all of the different functionalities of our actual budget server are now in here. So we have one agent that takes care of account management, one that takes care of transactions, one categories, and one payees. And to visualize this a little bit better, I should show you what that looks like. So to show you what we're really working on, this is just a simple little budget tool. And in here we have a checking account just with some demo data that I entered in here. Some of this has categories, some doesn't, some have payees, some don't. All these transactions are in here. And you know, we have just this checking account in here, fairly simple stuff, but we want to do something interesting with this. So the Magentic orchestration is now in here. We will also, before we invoke this, before we actually take a look at this, what I think is very interesting in here is the Logged Magentic Manager. I pointed that out earlier, and what you can use this for, so I basically just copied the code from the standard Magentic manager and adapted it for my purposes. And you'll find it on GitHub in the Semantic Kernel repository. And what you see here, it has different kinds of functions. It uses plan, replan, evaluate, prepare, final, answer, prepare task fast, and so on and so forth. What I did here in the get response async, I added some code to actually expose the messages that are sent by an agent. And I did that by just hooking in here. It gets the internal chat history. I just take the last chat message here that gets added, which is the user message, or a user coded message, not something that we humans put in there, but the agent puts into the chat history on our behalf. And then when the response is streamed back, I capture that as well with the chat formatting. So I have that in my UI as the debugging output. So we can see what's going on for this demo. All right, let's run this. And we will ask it, what is the current balance of my checking account? So now here we go. The first one is used from the templates that we have in the Magentic manager here. So let's just quickly look at that again. There are certain prompts that are predefined here that you can modify to your liking. One of them is the verified facts, or the analyzed facts one. The first one that is generated, that you can see here, is to gather information based on the request that the agent got. It comes up with an answer to that. Given our verified facts here, the user is asking about the current balance of their checking account, facts to look up, facts to derive, and educated guesses. So self-organizing in this case. Then the user sends back an email or a message with the capabilities of the agents that we have. And then the agent is asked to define a plan that addresses the user request. The assistant then says, okay, I need the account agent to retrieve the current balance. We go back into the loop planning or analyzing, replanning stage. Then the assistant is calling out to the account agent to get accounts without arguments. It finds the checking account. It uses the ID from the checking account to call the get account balance tool, and it retrieves the balance. And the account agent then adds to the agent thread that we have a balance of $10,025. It again goes through its thinking steps. And then in the end, when it's done with its thinking steps, and it says that is task progressing is false, is task complete is true, is task in loop is false, everything's good, the checking account balance has been successfully provided. And then we have a final synthesization step that then results in a final answer. So the only thing that the user would see in this case is this final answer instead of everything in between. That's what I exposed in that log Magentic manager for us. So let's try one more thing. Find all uncategorized transactions in November and find the appropriate payee and category for each, then update the transactions. So there is a function that doesn't work for me. Let's see if we can circumvent it with some prompting. There's a function that is supposed to update them in bulk, but it doesn't quite work for some reason. And it usually has to figure out to fall back to the single transaction update method, but we'll see. Maybe it gets it right here. So here, a little bit more interesting, a little bit more complex too than just finding the balance that all of the other agents so far could as well. Now it analyzes the request to find all uncategorized transaction in November, and then it splits it apart, appropriate pay and category for each uncategorized transaction, and updating the transactions one at a time. There's going to be a whole lot. It sees that, okay, I need the transaction agent, I need the payee agent, I need the category agent, and then I need the transaction agent again. So very good plan here, really. Let's see if it can execute on it. It got all uncategorized transactions here. I assume these are 12. So far, so good. Here we go. Found 12 uncategorized transactions in November, which is correct. We have 12 uncategorized transactions here. And then it starts to go through this. Let's see how far it is. So as you can imagine, now this is a self-organized system and it tries its best to do what we asked it to do. So it starts to update transactions here. I would assume that we should slowly get some change in that actual UI. Let's see. It says the request is far from complete. Transactions have been identified, but none have yet been assigned payees or categories. Okay. And this is a fairly complex task. Again, it depends a little bit on the model, if it can do this kind of complex task. If it's not big enough, and I'm using GPT 4.1 mini right now, if it's not complex enough, not big enough, the model, it is easily overwhelmed by too many of these calls. And I think we start to see that here. So let's try something else. As we can see here, it knows that the user request is not yet started and that we first need to know which November transactions are uncategorized. I would assume, yep, there we go. It pulled all of those and sent them back to GPT. It now is processing all of them. So this is quite a hefty task if you think about it. It gets a bunch of transactions, 12. It needs to then pick the correct agent, in this case a payee agent, to suggest a payee. It needs to suggest categories for each of them, and it then needs to update all of them. So there's quite a few tokens involved to do all of this. And if you have a use case that requires a large model like GPT 5.1, you'll have to try to make this as efficient as possible to not spend a whole bunch of money on output tokens. This, it's done. Let's see if it actually did anything. And there we go. It was able to add the missing categories here, I think pretty decently. Let's see. With Walmart, with groceries, with gas station, gym, auto insurance company. Did the best can with no information on in the actual nodes. So I think pretty good job. That's, I think, a pretty decent demonstration of how Magentic orchestration works. So we go back here, we see the debug output. It went and used the single update transaction method here. Very good. And yeah, it was able to do all of this. Again, there's lots and lots of GUIDs in here, so a lot high token usage, but it works out. It did all of that, and I'm pretty happy with it. So just to go back real quick, during this session, we've accomplished most of the things that I wanted. There is an added bonus here, a completion agent chat mode with memory. I'll cannot in this code presents anymore show you this one because we are definitely out of time here. But what I will do is I will upload this on GitHub and make it accessible for you. And then you can have a look at this yourself. It is basically adding the mem0 API context provider, AI context provider. And that is used to create memories from the user inputs. So if a user always wants a certain format, this could help you achieve this kind of memory for your agents. Anyhow, with all of that said, we took a look today at how to build intelligent systems with Semantic Kernel. We looked at how you can create your first Semantic kernel using the kernel builder, how you can extend those with plugins, either native C# code plugins or MCP plugins that are either Node or Python or whatever have you that you can add to your project. We looked at how you can do simple function calling with that. We looked at how you can create your first agent, what the difference is between an agent and the function calling chat itself, and how you can orchestrate all of those agents with your orchestration patterns. So if you have any questions about this, you can find me online at the following email addresses and places, and you can also get, since you are you have subscribed to this channel, you have the opportunity to also subscribe here using this QR code to get a free Code magazine subscription. So feel free to copy that email, that URL or the QR code, and let us know what you think about this in the comments. Please don't forget to subscribe and ring that bell for when we have a new Code Presents dropping. Look at codemag.com for our latest events and trainings. And if you have any questions, don't feel free to reach out, and I would be happy to answer any of your questions. Thank you again so much. You have a wonderful day, and see you next time at Code Presents.